Hello my great viewers, I want to welcome you once again to another awesome moment in our class. Today we'll be looking at laws of indices, the introductory aspects of indices. In our previous class we dealt with simple algebraic equations. There are several laws of indices which I'll be discussing, and I want you to follow me closely because if you understand this, you'll be able to understand the next aspect we'll be diving into after now, which will be solving certain indicial equations. Okay, I will start by letting you know the meaning of indices. Now, the word index is a singular term which means raised to the power. So by indices we simply mean powers to which a number or a quantity can be raised. So let's look at the different laws of indices. We have the law of multiplication. The law of multiplication states that if the bases of quantities are the same, then their powers can be added. For instance, if we have a raised to power b times a raised to power c. In this case, a is the base, b and c are the powers which we can now call indices. Now since the bases are the same, it means we can add a power. So this is going to give us a raised to power b plus c. This is the law of multiplication. Now we have the law of division. Now this law states that if the bases of quantities are the same, then the power of the numerator subtracts the power of the denominator, meaning the power of the dividend subtracts the power of the divisor. Assuming you have a raised to power b divided by a raised to power c, this is simply going to give us a raised to power b minus c. And in all these cases, the basis must be a non-zero base, meaning that the base can never be zero for these laws to hold. This applies to all the laws of indices. Now, we also have the law of zero index. Now, the law of zero index states that any quantity raised to the power of 0 is 1, irrespective of the value of that quantity. For instance, if we have a raised to power 0 is equal to 1. If we have y raised to power 0 is equal to 1. If we have 10 raised to power 0 is equal to 1. If we have 1 million raised to power 0 is still equal to 1. It does not matter the value of the quantity, as long as it is raised to the power of 0, it is 1. That's the law of zero index. Then we also have the law of negative index. This law states that when a quantity is raised to the power of negative index, the result is the reciprocal with the base raised to the power of the positive index. What does that mean? If we have a raised to power minus 1, this is showing the law of negative index because the power here is negative. So it's saying that it is the reciprocal, which is 1 all over the base raised to power the positive index. I believe you understand what is reciprocal. Okay, let me explain. Assuming we have a, ordinarily a is equal to a all over 1 if I'm to express it as a fraction. Then by reciprocal, it simply means the inversion of this number, which is 1 all over a. So that's why we have 1 all over here. Then the base is raised to the power the positive index. Then we also have the law of power index. Now the law of power index simply says that when a quantity is raised to a certain power, which is as well raised to another power, then the two powers are multiplied. For instance, if I have a raised to power b and this is also raised to power c, then the law of power index states that a will be raised to power b times c, and that gives us a raised to power bc. Then we also have the law of fractional index. Now that means quantity this time we are looking at is raised to the power of a fraction. Now what does the law state? The law states that if a quantity is raised to the power of a fraction, it is resolved by finding the nth root of the denominator, which is altogether raised to the power of the numerator. By that we mean, let's take an instance, a raised to the power of b all over c. This is a fractional index. So it states that it is resolved by finding the nth root of the denominator, which is altogether raised to the power of the numerator of that fraction. This is showing the C root of A, which I mean the nth root, because I use letters to represent the fractions. And then all together raised to the power of b. Okay, let me take practical example with figures. 8 raised to the power of 2 all over 3. This is going to give us the third root of 8 all together raised to the power of 2. That's the implication. The third root of 8 all together raised to the power of 2, which if I am to resolve it is simply going to be 2 raised to the power of 3, because 8 is 2 times 2 times 2. So the third root, and then all together raised to the power of 2, of which in this case 3 cancels 3 here. We are left with 2 raised to the power 2 equal to 4. Okay, so this is a simple illustration of the power of fraction index. By this, I've been able to introduce to you all the laws of indices. Now I want to solve just one problem that will illustrate some of these laws put together. Looking at this problem here, you can see that we have the expression of the different laws of indices which I just talked about. For instance, we have the multiplication law trying to play out in the numerator of this whole fraction here. And then we also have the law of division playing out here because we have a term all over another term. Now let's see the application of these laws. Now according to the law of multiplication, we say if the bases of the quantities are the same, then the powers can be added. But here if you look at here, 8 and 2, which are the bases of these two different terms in the numerator, are not the same. So what do? We think of a way to make the bases the same so that the law can apply. 8 is the same as 2 times 2 times 2, which is 2 raised to the power 3. So by application of that, I'm going to have 2 raised to the power 3 x minus 3 times 2 raised to the power x all over 4 raised to the power x plus 1. Now you can see power law has been introduced here, which is when a number is raised to a certain power, then raised to another power. So in this case, we are going to multiply the powers by opening the bracket in the power section here. So that is going to be 2 raised to the power 3 times x, which is 3x, plus times minus, which is minus 3 times 3, which is 9. Then I have times 2 raised to the power x all over 4x plus 1. Now let's resolve the numerator. Since the bases are the same, we cannot add the powers, applying the law of multiplication. So this is going to become 2 raised to the power 3x minus 9 plus x all over 4 raised to the power x plus 1. And this should be equal to 2 raised to the power 3x plus x gives us 4x. So we have 4x minus 9 all over. Now let me make this 4 to have the same base as 2. And 4 simply means 2 times 2, which is 2 raised to the power 2. So this is going to be 2 raised to the power 2 in bracket x plus 1. Now I'm going to open the brackets in the power of the denominator. 2 raised to the power 4x minus 9 all over. Then let's open that bracket. We have 2 raised to the power 2x plus 2 times 1, 2. Now we have simplified this problem to have just one base up and one base down, and the two bases are the same, meaning we can apply the law of division here, and that states that the power of the numerator will subtract the power of the denominator. So this is going to be equal to 2 raised to the power 4x minus 9 minus 2 raised to the power 2x plus 2. And that will be equal to 2 raised to the power 4x minus 9. Let's open this bracket. We're going to have minus 2x. Minus times plus gives us minus. So we have minus 2. Now let's simplify the powers here. We are going to have 2 raised to the power 4x minus 2x gives us 2x Minus 9 minus 2 gives us minus 11. This gives us the solution to this problem. Wow. I want to thank you for watching this video to the end, and in case you have a question, I want you to do what to ask at the comment section below, and I will answer the questions. And in case this is your first time of visiting UMass Media, I want you to do us a favor by hitting the like button, subscribing to this channel, and turning on the bell notification so that anytime UMass Media drops another wonderful video, you are going to be notified. Just log into your YouTube, check your notifications. You'll see us there. See you in another video. Thank you.